Hello everyone, and welcome to today's session on Kubernetes security. As Kubernetes continues to dominate the container orchestration landscape, securing your clusters has become more critical than ever. In this session, we'll explore the key security challenges in Kubernetes, discuss best practices, and walk through practical steps to secure your clusters. By the end of this session, you'll have a solid understanding of how to protect your Kubernetes environments from threats. Let's dive in. Why Kubernetes security matters. Before we talk about how to secure Kubernetes, let's understand why it's so important. Kubernetes is a powerful platform, but its complexity and flexibility also make it a target for attackers. Here are some key risks. Misconfigurations. Default settings are often insecure, leaving clusters vulnerable. Container vulnerabilities. Images may contain vulnerabilities or malicious code. Unauthorized access. Weak authentication and authorization can lead to breaches. Network attacks. Exposed services or insecure network policies can be exploited. A single vulnerability can compromise your entire cluster, leading to data breaches, service disruptions, or even regulatory penalties. That's why securing Kubernetes isn't optional, it's essential. Key areas of Kubernetes security. Securing Kubernetes involves multiple layers. Let's look at the 4 key areas: cluster setup and configuration. Use a secure configuration for the control plane and worker nodes. Disable unused features and APIs. Enable role-based access control, ABAC, to limit permissions. Authentication and authorization use. Strong authentication mechanisms like TLS certificates or OIDC. Define granular RBAC policies to enforce the principle of least privilege. Regularly review and audit permissions. Workload security scan container images for vulnerabilities before deployment. Use pod security policies, PSPs, or their replacements, e.g., Kyverno, OPA Gatekeeper, to enforce security standards. Run containers as non-root users and limit privileges. Network security use. Network policies to control traffic between pods. Encrypt traffic using TLS. Limit exposure of services to the internet. These areas form the foundation of a secure Kubernetes environment. Best practices for Kubernetes security. Now that we know the key areas, let's discuss best practices to secure your Kubernetes clusters. Harden your cluster. Keep Kubernetes and its components up to date. Use tools like KubeBench to check for compliance with the CIS Kubernetes benchmark. Secure API access. Enable audit logging to track API requests. Use network policies to restrict access to the API server. Protect secret store, sensitive data, e.g., passwords, tokens, and Kubernetes secrets. Encrypt secrets at rest using encryption providers. Monitor and audit use tools like Falco or Sysdig to detect suspicious activity. Regularly review logs and audit trails. Implement network policies. Define policies to allow only necessary communication between pods. Use tools like Calico or Cilium for advanced network security. Adopt a zero-trust approach. Assume that no user or workload is inherently trusted. Continuously verify identities and enforce strict access controls. By following these best practices, you can significantly reduce the attack surface of your Kubernetes clusters. Example: securing a Kubernetes deployment. Let's apply what we've learned to a real-world example. Securing a Kubernetes deployment for a web application. Cluster setup. Use a managed Kubernetes service, e.g., EKS, GKE, AKS, with built-in security features. Enable RBAC and disable anonymous access. Authentication and authorization. Integrate with an OIDC provider for user authentication. Create RBAC roles with minimal permissions for developers and admins. Workload security. Use a private container registry and scan images for vulnerabilities. Apply pod security policies to restrict privileged containers. Network security, define network policies to allow traffic only between the front-end and back-end pods. Expose the application using an ingress controller with TLS termination. Monitoring and auditing, deploy Falco to detect runtime threats. Set up centralized logging and alerting for suspicious activity. This example demonstrates how to apply Kubernetes security best practices in a real-world scenario. Summary. To recap, securing Kubernetes requires a multi-layered approach, from hardening your cluster to implementing network policies and monitoring for threats. By following best practices and staying proactive, you can protect your clusters from evolving threats.